We are meeting again because I have with me Dr. Ameya Dravid, who has published another paper. Ameya has been now out of the lab for the last 1.5 months. He's currently pursuing his postdoc at Georgia Tech in USA under Ankur Singh and Andres Garcia. And we have published a paper in Journal of Biomedical Materials Research Part A. And we are here to discuss that. So, Ameya, how have you been doing?
I've been doing great, Richard. Always happy to be here. The transition from my PhD to this lab and in Atlanta has been really smooth, so I'm thankful for that. And yeah, great to be here again.
Awesome. So, Ameya, let's talk about this paper that you have published in JBMRA. Could you tell me what this paper is about?
Yes. In this paper, we have developed a biomaterial-based approach for delivering a potent omega-3 fatty acid called resolvin D1 for the treatment of osteoarthritis.
Cool. And since we've also done this in the past as well using a similar approaches, could you tell me what is new in this paper? How is it different from the previous publication?
Yes. In the previous study that we had published, the mice model that we had used used lean mice. Now, the way this study was done is in lean mice, the model that we had used is a great example of post-traumatic osteoarthritis, which is what we see as sports injuries or accident injuries in humans. However, in the recent few decades, with the acceptance of a high-fat diet, high-fat based diet, and also the increase in a sedentary lifestyle of humans, there's an increased agreement or increased association between obesity and osteoarthritis. In this study, we using a more challenging mouse model, study the effect of a biomaterial-based delivery vehicle in an obesity-related osteoarthritis model. So in this paper, the model is more challenging to treat, and we show from our results that our vehicle, our delivery method is able to treat that particular disease.
Cool, cool. And so, so what are the implications of this study? What is the novelty? How do you see this panning out in future?
The novelty aspect of it, this is the first time that we are showing that a biomaterial-based delivery approach for treating osteoarthritis. From the previous papers, which had shown efficacy of this particular molecule, namely resolvin D1, we are able to achieve efficacy at about an eighth of the dose that was given initially. And this was only possible because of the biomaterial-based approach. And we think that this could be a really effective way to treat osteoarthritis because first of all we're making the delivery more efficient, and hence this will change the way we think about treatment of osteoarthritic. And implications in the future, the next steps to go about it is since we have done these experiments in mice, we further plan to perform these experiments in a higher animal model, for example, osteoarthritis of dogs or goats, and uh, and then evaluate the efficacy of these formulations in these animal models. One of the major reasons why we need to do this is because of the size of it, size of the animals. In mice, for example, the way the chondrocytes are arranged in the cartilage is quite different from that in the large animal models because of the weight bearing and the way these organs develop. Uh, and hence we look forward to the experiments from large animal models.
Awesome, great. Thank you for giving us that take on this paper. Always a pleasure to talk to you, Ameya, and I wish you good luck for your postdoctoral studies.
Thanks, Rajat. Always a great pleasure to be here.